Okay, so we're going to try problem 61 here. A steel ball is dropped from a building's roof and passes a window. Okay, so it doesn't tell you how far down that window is. I'm going to say that window is like here. And then this is Y1 at the top of the window. This is Y2 at the bottom of the window. And then you have Y3, which is the ground. Okay, so it says the steel ball is dropped from the building's roof and passes a window, taking 0.125 seconds to fall from the top of the window to the bottom of the window. A distance of 1.2 meters. So that's the distance between Y1 and Y2. It then falls to a sidewalk and bounces past the window. So it falls to the sidewalk, bounces back past the window, moving from the bottom of the window to the top in 0.125 seconds. Assume that the upward flight is an exact reverse of the fall. The time the ball spends below the bottom of the window here is 2 seconds. So just be careful, because you know it bounces, and the way they have this worded, that they're saying that basically it's 1 second down, 1 second up, right? Because it's only spending a total of 2 seconds, so that includes the bounce. Okay, so in the problem, basically you're going to have several times here. You have a time 1 in the beginning, time 2 in the window, and then time 3 where it takes to bounce. But remember, this is 2 seconds here, bouncing back and forth, so it's 1 second basically each way. So we're told basically that y2 minus y1 equals 1.20 meters. And then we're told t2 minus t1 equals 0.125 seconds. So if we plug this into equation 2.15, I think it is. Write that there. You're going to get y2 minus y1. Make that. And then we're going to be looking for velocity 1. And then you're going to have t2 minus t1. And you're going to have plus 1/2 g t2 minus t1 squared. And then we have the information here, so we can put in 1.20 meters equals v1, what we're looking for, times 0.125 seconds, plus 1/2. I think I just wrote g out of just subconsciously thinking about it, but this is acceleration, right? So it's g, so it's 9.8 meters per second squared. And then you have the time again, which is 0.125 seconds. That's squared. This is meters per second squared. And then we solve for v1. So doing some algebra, rearranging it, you should get v1 equals 8.99 meters per second. So that gives us the first information. This v1 is then information for the second part of the fall. So if we use equation 2.16, which is then your v squared equals v naught squared plus 2 times the acceleration, and it uses x in the book, we're going to use y. So yeah, we're doing this equation and we want y1. So again, the initial velocity, because we started from the very top and you just drop this thing, is going to be 0. So this will go away. We have this velocity, so we're going to put 8.99 meters per second equals, and then this 0 goes away, 2 times 9.8 meters per second squared, and y1. Again, rearranging y1, you should get 4.12 meters. So that gives us the first distance. So hopefully you got this part. I didn't write this very well, so I'm going to go ahead and start erasing. It's on video, so you can rewind it to see what it was, I guess. So we are going to go back and now look for y3. So we're again going to use equation 2.15, and it should look like this. This time with y3 minus y1 and then time 3 minus time 2 squared. Okay, so going through and plugging these values in, you get y3 minus what we found before, 4.12 meters, equals the V1 we had before, 8.99 meters per second. When you do T3 minus T2, you're actually adding it, so you know again when this thing went down, it goes 1 second down, 1 second up. We're only looking for one direction, right? So you're going to say it goes 1 second up. We know the time it takes to cross from here to here is 0.125 seconds. So you add those two together and you should get 1.125 seconds. And then you have plus 1/2 times 9.8. And then again the 1.125 seconds squared. So again, rearranging this, solving for y3, you should then get as a final answer the overall height of the whole building is 20.4 meters.